Great to be here. And congratulations. You have all chosen to be born at the best, the most interesting, and the most important time in all of human history. Well done. Give yourself a pat on the back. Now, I realize this may seem a strange remark given the terrible pandemic and the alarming polarization of our politics, but the data does say I'm right. If you chart the economic history of the world over the last 2,000 years, you'll see that pretty much nothing happened until the start of the Industrial Revolution. And then things changed very fast. Until then, all the metrics of human welfare remained pretty much static and low. But when the Industrial Revolution got going, they started to improve dramatically. Not just GDP, but also health, lifespan, decline in child mortality and death during childbirth, literacy, and even levels of inequality. This remarkable progress is due largely to the exponential growth in the power of our technology. And this exponential technological improvement is continuing, and it's going to make our world very exciting. If we're smart, and perhaps a bit lucky, we can use our technology to make our world truly wonderful. The most powerful of our technologies is, of course, artificial intelligence. We know this because in the last 2 decades, AI has taken on the best humans at 4 big challenges. And quite frankly, it has thrashed us. In 1997, an IBM system called Deep Blue beat Garry Kasparov, perhaps the best ever human chess player. And Kasparov was very grumpy about that. He accused IBM of cheating, and he was probably right. In 2011, another IBM system called Watson beat the best human contestants in a US TV quiz game called Jeopardy! This time, the human loser, Ken Jennings, was very gracious in defeat, saying, "I, for one, welcome our new robot overlords." In March 2016, a system called AlphaGo beat the best ever human player of our most complex board game. AlphaGo was developed by DeepMind, based in King's Cross in London, but it's owned by Google. The game of Go is held in very high regard in China, especially in military circles, where it's regarded as a great strategy training platform. DeepMind's achievement prompted China to go all in on AI, which means that there is currently a duopoly on AI between China and the US, with Europe and everyone else very far behind. But it was last year that we took the final blow. An artificial intelligence developed in Singapore managed to assemble an IKEA chair in 9 minutes, and it didn't swear. That's when you know it's game over for the humans. Now, the last 2 contests, Go and IKEA, used a different type of AI from the first 2. They took place after the Big Bang in AI that happened in 2012, when a British computer scientist called Geoff Hinton figured out how to apply a branch of statistics called machine learning to AI, and in particular, a sub-branch called deep learning. Up until then, AI had done some impressive things, like beat the best human chess player, but no one had found a profitable use for it. Since the Big Bang, AI has made money, lots of money. To oversimplify, deep learning works in a similar way to the human brain. Machines can now learn, and they can be creative. DeepMind did not teach AlphaGo how to play Go. They taught it how to learn how to play Go. Thanks to deep learning, machines can now recognize faces better than you can. They're overtaking us right now in speech recognition, and they're catching up fast in natural language processing, which is when information is ingested in natural language, processed in some way, and the result delivered back again in natural language. Now, what has made all this possible is the extraordinary growth in the power of our computers. You've probably heard that the phone in your pocket has more compute power than NASA had at its disposal when they sent Neil Armstrong to the moon. And that is true. but it's out of date. A good toaster now has more compute power than NASA had in 1969, which really makes you think how incredibly brave those astronauts were to go into space relying on the intelligence of a toaster. The other thing you need to make the current cutting-edge AI work is data. Lots and lots of data, and we are creating tsunamis of the stuff. So let's look at a couple of the short-term impacts of all this. Today, Siri in your phone is a bit silly. She can answer a simple question fairly well by looking it up on Wikipedia, but if you follow that up with anything remotely complicated, she's lost. Fairly soon, Siri's going to get smart. In the next few years, you will have conversations with your digital assistant, and you'll send it off to do errands for you. Also coming soon are self-driving vehicles. The self-driving cars built by Google's spin-out company Waymo have driven 10 million miles without causing a significant accident. On average, they drive 11,000 miles before they have to hand over to a human. It turns out to be very difficult to get the last few degrees of perfection right, and it's taking longer than people thought. But Waymo's cars prior to the pandemic were driving around with members of the public in the back of the car and no human driver or chaperone in the front. There's just a pilot, but it won't be many years until they're ready for prime time. And we should be excited by this and look to hurry it up, because human drivers kill 1.3 million people every year around the world and maim another 50 million. Road accidents are the single biggest cause of death globally for 15 to 29-year-olds. Looking beyond the short term, what comes next? For many decades, computers have been getting twice as powerful every 18 months, and this is known as Moore's Law, after the Intel co-founder, Gordon Moore. Now, you will hear people say that Moore's Law is dead or dying, but it's not true. It's evolving, which is what it's always done. Computers, and therefore AI, are going to continue their exponential improvement for many years to come. There is plenty more. To illustrate the astonishing power of the exponential growth that we're seeing in compute power, imagine walking 30 normal steps. You'd go about 30 meters. Now imagine that you could walk 30 exponential steps. So your first step is 1 meter, your second step is 2, your third is 4, and your fourth step is 8 meters, and so on. Your 30th step would take you to the moon. Or to be more specific, your 29th step would take you to the moon, and your 30th step would bring you all the way back again. In exponential growth, each step is equal to the sum of everything that's gone before. In exponential growth, like the growth that we're seeing in compute power, what happened yesterday is trivial compared with what happens tomorrow. You're always at the beginning of the journey, and we are only at the beginning of our AI journey. In the medium term, AI will have a huge impact on labor, on jobs, because it will automate many of them. Now, of course, automation is nothing new. We've had it since well before the start of the Industrial Revolution. Agriculture is the poster child, for the simple reason that it used to be most of the economy. In 1800, 80% of all American workers were employed on farms. And then farming got automated, or to be specific, mechanized. And that number fell to 40% in 1900, and it's around 1% today. Now, this transformation caused a lot of inconvenience and suffering. People had to move to cities, and some of them died. But in the long run, it wasn't a problem for humans. When machines stole our muscle jobs, we still had our cognitive abilities to fall back on. And the grandchildren of those farm workers now do safer and usually more interesting work in offices and shops. But it didn't work out so well for the horse. The horse had nothing to offer but muscle power. In 1915, there were 21.5 million horses working in America, pulling vehicles, working on farms. And it turned out that 1915 was peak horse. The horse population of America today is 2 million. 21.5 million down to 2 million is very severe technological unemployment. Past rounds of automation have mostly been mechanization, the replacement of muscle jobs. But what's coming now is cognitive automation. This again is not entirely new. Back when I started work, there were secretaries in most offices. In 1978, secretary was the most common job title in most American states. The secretaries were displaced by the PC. And today, the most common job title in most states is truck driver. But it won't be for much longer. Self-driving vehicles will be ready for prime time sometime in the next decade, and they will penetrate the commercial fleet quickly because the human driver contributes around half the cost of the vehicle she operates. There are 5 million professional drivers in the US. What will they do next? Well, traditionally they might have worked in a warehouse or a call center, but automation will reduce headcount there too. And it's not just blue-collar jobs. Machines can do many of the tasks now assigned to human doctors and lawyers. Machines have unfair advantages over humans. They don't get tired, they don't get drunk, they don't get irritable or sick. But most important, they're getting twice as good every 18 months or so, and we aren't. Now, in the short term, I don't think this will lead to widespread technological unemployment. And by short term, I mean this generation. Automation means greater efficiency, and that means more wealth, more demand, and more jobs. And as long as there are a reasonable number of jobs which humans can do and machines cannot, that means jobs for humans. But the humans will have to change jobs more often, and indeed change careers more often. AI may not replace humans in all jobs, but humans who understand and can work with AI will replace those who don't. There will be more churn in the job market, more retraining, and we're not very good at this yet. We need to get much better. But in the longer term, perhaps, as I say, in a generation, I do think we have to take seriously the possibility that there will be technological unemployment. Now, many economists and pretty much everybody running a tech giant says this is the Luddite fallacy. Automation hasn't caused lasting unemployment in the past, and so it won't this time either. And frankly, this is a terrible argument because it relies on the assumption that past performance is a guarantee of future outcome. And if that was true, we wouldn't be able to fly. And we have seen technological unemployment in the past. Remember the poor old horse. To deny the possibility that it could affect humans is dangerously complacent. Thanks to the exponential progress, the machines that we have in 10 years' time will be 128 times more powerful than the ones we have today. In 20 years' time, they'll be 8,000 times more powerful, and in 30 years, 1,000,000 times more powerful. We really can't be confident that these machines won't take pretty much all our existing jobs. Some people think that we will all do caring jobs. We will all be each other's nurses and therapists because machines are not conscious, therefore they have no empathy, and therefore they can't do those jobs. I have my doubts. Machines can give a very good impression of caring, and often that's what counts. Japan is at the forefront of the greying of society, and they don't allow much immigration, and they're technophile. They are increasingly using robots in elder care. And it turns out their elderly people really like being looked after by robots. And I think the reason might be that you can tell a robot the same joke 1,000 times a day and it just doesn't care. I think we need to work out how to survive a jobless future. In fact, we need to figure out how to make it wonderful. And I think we can. A world in which machines do all the jobs could be a world in which humans do whatever they want to. Learning, playing, exploring, socializing, creating, having fun. We could have a second Renaissance. In fact, I think the people who insist that we will all do jobs forever, I think they are the true pessimists. Of course, there are a few little problems, and the one that springs to mind first for most people is meaning, but I think this is a mistake. I think there are two groups of people who prove you don't need a job to have meaning. The first group is comfortably off retired people. Because of my age, I know a lot of these people. They're busy and happy, and they have absolutely no desire to get another job. Being retired and poor is miserable, but it turns out that being retired and comfortably off is really rather good. The other group is aristocrats. For centuries, they had no jobs, and there was no great wave of existential despair because of lack of meaning. I think the real problem is money, or access to resources. How do we pay for all the people without jobs? Now, at this point, many people shout universal basic income, or UBI. There are several problems with UBI, but the really big one is the little word in the middle, basic. It means that the best we can do forever for all the jobless people is to provide them with a basic income, a subsistence income. But in that case, society will have failed and probably won't survive. What we have to do is make everybody rich, or at least comfortable. Now, this may strike you as a little weird, but I think we can make everybody rich if we can evolve the economy of abundance, sometimes known as the Star Trek economy. This involves bringing the price of everything you need for a really good standard of living down close to zero. Not completely to zero, because you want to retain the market, which is the best mechanism we've ever invented for resource allocation. Now, it sounds crazy, but you can see how it could happen if you think about the music industry. When I was young, it was impossible even for a rich person to listen to all the music that might take their fancy. Today, that costs £10 a month. The big danger, it seems to me, is panic. When enough people believe that technological unemployment is coming, if they don't also believe that abundance is coming, they may start to panic. And when we panic, we elect very dangerous politicians. We need a plan for how to handle these developments. We need to develop a consensus that technological unemployment is probably coming, not now, but probably in a generation. And that with the economy of abundance, it can make our world wonderful. So I said at the beginning that today is the best time ever to be human. And this is still true, despite the pandemic and despite our polarized politics. But if we navigate the transition through the economic singularity successfully, our future can be beyond wonderful. There are risks and challenges ahead, but we can overcome them and make our world even better, much better.